Good afternoon, and thanks for joining our webinar today on multi-use residential site design. Again, what we're going to take a look at today is a little bit of storm and sanitary analysis. And from that storm and sanitary analysis, there's a few things that I want to get across. So what I've put together is a small PowerPoint in terms of things that we want to be able to talk about. And clearly with the things that are going on around the country, stormwater management is a very important and critical thing. So those of you who've been using Civil 3D, hydroflow extensions, and also storm and sanitary analysis, one of the things we want to be able to do is kind of get an idea of some of the things that are going on. So first, I want to ask a couple questions. So what are the overall capabilities of storm and sanitary analysis? Another question that we have is, does storm and sanitary analysis support Esri and GIS data? On the other hand, some of you may think, why can't I just use hydroflow extensions? And one of the other things that typically comes up is the idea that, is there any program that addresses stream restoration? So one of the things that I want to be able to do is, from this webinar, I want to be able to kind of describe some of the tools that you get straight out of the box with Civil 3D. I also want you to kind of try and determine what's the best suit, the best tools that you can use and that will suit you based upon the requirements that you may be asked of. And then also you can determine the competitive hydrology and hydraulics products that kind of save you money. And then there's some tips and tricks for kind of using some of those programs. So as we move on, I want to talk about some of the hydrology modeling capabilities of storm and sanitary analysis. So as you can clearly see, and I'm not going to read the long list of items, but based upon what individuals typically do with TR25, TR20, TR55, and then EPA SWIM, SP SWIM, Santa Barbara Unihydrograph, and then rational and modified rational, depending on what site you may be working on. Those are just some of the capabilities. So one of the things that you kind of look at, because most people say, well, I have hydroflow, why can't I just use hydroflow sometimes? And you know, hydroflow does kinematic wave and steady flow. Storm and sanitary analysis also does kinematic wave and steady flow, but also does hydrodynamic. So storm sewers, combined sewers, open channel streams, bridges, culverts, detention ponds, force mains, and then overflow routing. And then kinematic wave and steady flow can't model backwater. So similar to storm sewers, hydraulic grade line spikes, hydrodynamic can model backwater effects, surcharging, looped pressure flows, tidal outfalls, and interconnected ponds. So if someone thinks about interconnected ponds working with hydroflow, you start running into issues. So it's just something to keep in mind in reference to hydroflow. And then in SSA, the equations used for channel and partially filled conduit is Manning's Q, and then steady flowing kinematic wave, the slope is the pipe slope. For hydrodynamic, it's the friction slope. So you just want to keep those things in mind, and clearly when you're in a pressurized system, now you're talking about Hayes and Williams or Darcy Weisbach that replaced the Mannings. And the other thing that I wanted to just make reference to was this idea when you're moving data back and forth from Civil 3D. There's a couple things that You want to be able to recognize in 2018 from 2015, or even a standalone version of HydroFlow in SSA. There are some HEC 22 inlets that have been addressed in terms of working with inlets and gutter spread. So this parts conversion is based upon moving data from the hydrology programs into Civil 3D and back and forth. And on a small side note, Autodesk is kind of moving away from Part Builder. So there will be an upcoming webcast in reference to Parts Editor from InfoWorks that allows you to create your own parts, similar to what Parts Builder did with Civil 3D. So why use other packages, or why don't we use SSA? Sometimes it's just overkill using SSA. And the time to put the data in, you could do it with HydroFlow. So it kind of depends on what you're being asked to do. But clearly, if you're doing pressure and sanitary, HydroFlow is not going to be that for you. So you also want to be mindful of the river analysis extension that you get with Civil 3D while being on subscription, which allows you to automate HEC-RAS, cross-sections, TINs, digital elevation models, LiDAR data that you can utilize, extract cross-sections from, and then also bridge and culvert analysis. And then mapping of bank stations and overland flow links, locations, roughness, manage roughness for topographic map data. It allows you to do all those things. And then bridge scour computations for FHWA and DOT roadway studies. And then floodplain, generating flood maps. Clearly, you want to be able to utilize the data from Civil 3D in terms of flood maps and being able to edit and model those in a program such as HEC-RAS. So there's an extension that allows you to push data straight from Civil 3D into HEC-RAS, and the river analysis would be one of them. We're going to hold off questions because what I want to do is talk about where we're going in terms of this example. So one of the things that I've done is someone came about and inquired about, all the samples that SSA has straight out of the box. And I just want to show that really quick. So straight out of the box, there are samples in terms of projects straight out of the box. One of the things that most people have not seen yet is the idea of, what comes with these samples. So there's no verbatim verbiage in terms of a data set. They're just samples of different projects of data. So something as simple as this, where I can come in and say, select my profile plot, pick on my length and select show plot. Something as simple as that. The beauty of working with these tools allows me to kind of put in data and run analysis and then spit out reports. And based upon those reports, in terms of my hydrology. So the beauty also of working with Storm Sanitary Analysis is you have some visual effects in reference to output in terms of animation, in terms of running different analysis. So I'm just going to run this real quick, and then I'm going to get to what we're talking about today. So I'll select OK, and it's showing me my hydraulic grade line. It's showing me where it's overflowing out of a structure. If I run my analysis and I pick on that pipe, it's showing me how it's surcharging, time is surcharging, what's my design capacity, what's my peak flow analysis, things like that. It gives you that general information. And if I ran my output analysis, just as some, well, why do I have to upsize pipes? So I'm going to push my animation speed up, and then I'm just going to run it. And we'll say probably in the 9th or 10th hour there. I'm just going to run it. And it gives you an idea of what's going to happen during that storm event. So we're going to talk about some of those things, as simple as that may be. So we'll close that, no big deal. And then also, I'm just going to start a new program. But where's the data coming from that I am utilizing? Because I'm going to be talking based upon our time frame in reference to doing some things. And I've already kind of made some calculations and some assumptions in terms of to get an idea of how you can utilize this program outside of the visual program that you get with HydroFlow and some of the other programs out there. Storm Sanitary Analysis, very schematic in terms of what it brings to the table. So, for instance, what do I mean by schematic? That means that I don't have to have a 90 or 100 acre site actually in the program. It reads from runoff coefficients, friction in terms of numbers for the analysis. So we just want to keep that in mind. So the original question was, where did I get this example from? So this is a design example from the South Florida Water Management District, and it's just a residential site. It's telling me what my acreage is. It's telling me what's impervious, my buildings, my roofs, my roads, my parking lots. It has 2 lakes. It's telling me my impervious I have calculated. It's telling me what my minimum elevations are, my maximum elevations. It's telling me what year round in terms of rainfall events that my roads for a 10-year, a 25-year, and for the floors, a 14, 100-year storm. So here's the site. It's just a TIFF image. As you can see, there's some parking lot and buildings, and then there's some lakes, and then you got a receiving body of water. So from this image that someone has given me, it's got an outfall structure that's going down here into this body of water here, and it's leaving from these lakes. And right here, I don't even know if these lakes are connected, but based upon my hydrology method, I can make some assumptions. So then it's giving me my design criteria, computations, and just information that I need in terms of determining my 10, 25-year, and 100-year storm. It's even telling me specific what the stages for my curve data is. And then also, it's giving me my stages, discharge, and my weirs for my outfall structure. So it's giving me all the information that I need. And based upon this information, I've just kind of went through, and I'm going to use SSA to work through this example. So I'll come back to SSA. So with SSA, if I came to my file pull down, I can import. So how do I get this information in? So there's a couple different ways. I could have a Civil 3D drawing open. So one of the future webcasts that will be coming up also is the idea of using the InfoWorks product out of the AEC collection, pulling that data in, pushing that data to Storm and Sanitary Analysis, and then pushing that data to back to Civil 3D, and then back to InfoWorks, round tripping that data. So that's an upcoming webcast, just in case. But what Storm and Sanitary Analysis allows you to do is import specific models and data. So one of the things that we can look at is clearly HydroFlow Storm, and we can see EPA swim and XP swim, and then this layer manager. So the layer manager allows me to go in and grab a CAD file, a TIFF image, and other file formats that I can pull out in terms of working with an image and a drawing. So this image, if I come out, I'll just scroll down, no big deal. I have an image here as my example. It brings in that image. We can watermark that image to lighten it up if we wanted to. The beauty of working with this image is this image has a world coordinate file tied to it. So being able to push this data that I create from my storm pipes and my model back into Civil 3D, even though we're beyond that point because we're just making reference to hydroflow and storm and sanitary analysis. But you can clearly see it has a coordinate system tied to it. And I just select OK. And here's my image. So before I brought that image in earlier, I grabbed that image, I scanned it off that sheet that I showed you originally from the South Florida Water Management. I scanned the sheet, scanned the image to get it close to my 90 acres, and then I imported it in. And the first thing that we want to take a look at is, again, we want to take advantage of the different hydrology methods that we may be using. So on that example, the hydrology method that we're using, they want us to use is the Santa Barbara unit hydrograph. So if I go to the input in FFA in reference to the method, so if I go to project options, right now it's at EPA swim. So one thing to recognize when you're working with storm and sanitary analysis, based upon the hydrology method, it's going to give you either TR20, TR55, those type of things for time of concentration, or depending on if you use the hydrology method of modified, it's going to give you different options, but I'm going to use this Santa Barbara. And from this Santa Barbara, it gives you options for your time of concentration. We're going to use FFA. The reason we're using that clearly based upon the design parameters, but one of the things that you can do based upon FAA is you can have a whole area represented if you know the percentages of your pervious and impervious. So I'm just kind of, taking shortcuts and making some assumptions just to kind of say, this is not a typical site. So we're going to use FFA AA, and I'm just going to select OK. I did make reference to the differences between hydroflow and storm and sanitary analysis. And down here for your routing specifications, you can select specifically what you want to use. But again, interconnected ponds and things like that, kinematic wave and steady flow won't be able to address. And then also, I want to make this one total area. So the first thing I want to do is I want to make a subbasin. So I'll select add subbasin, and I'll just pick this point and pick this point. And again, this is about workflows and the tools that you would want to use. And if I just right click, I can select done. So it creates a basin, subbasin for me. So in the subbasin, now I want to just go to my select button, pretty straightforward, and I'll double click on that subbasin. So from that subbasin, there's a couple things going on. It says 99 acres. This site is 95 acres. We go back to the idea of schematic. And then it's telling me what my impervious area is, and it's telling me what my pervious area is and what the lake is. So one of the things that I want to be able to do is I need to determine what those areas are. So it's saying in my design parameters for my pervious area, that's like 34 acres. And it's saying the rest is impervious. So roads and parking lot, 41 acres, the lake is 10 acres, and then the building roofs is 9 acres. So I just divide 95 by 34 to get my percentages. So the first thing that we want to do is we got our hydrology method taken care of. We want to look at these physical properties now. So the area's 95 acres. The curve number, in terms of my area, we can look those numbers up. So the first thing is this area is my pervious area for my curve number. I can look that up with a table. So some pretty straightforward things. My impervious area is 65%. So I'm just going to close that. And I've already calculated what that is. That's just 65. So my pervious area, which would be like grass, that number is going to be grass cover 75%. That area, that number is going to be 74. So I just put in 74. And there are numbers that are defaulted in here. The numbers that are defaulted in here are based upon the defaults straight out of the box. And you can change those at any point in time. So one of the things that we also need to do is, well, what's the farthest point that's going to travel to these lakes? So the ideal is combining the lakes. So I'm going to look at the furthest lake from this point here. And I can use this little measure tool. And from here, I'll pick this little measure tool and I'll pick it, right click and select done. And it tells me what that number is. So that actual number that I wanted it to be is 1505. And again, for time purposes, I'm going to select close. So from that, now I want to address the lakes. So from the lakes, we need to put in a storage node. So up here at the top, we'll just select add storage node. From this storage node, I'll just put it right here. I'll pick my select button, and then I'll double pick on the storage node, and it tells me this is a storage node. The storage node represents my lake. So I'm just type in lake as my storage node. Again, this is a mixed use. So this storage, that's going to be 10 acres, right? It's combined with the both lakes. It's 10 acres. So the first thing that I want to recognize, the idea with the physical properties of this lake, is the invert elevation, which I grabbed from the document, is 5.5. And that raises 6 feet for my maximum elevation. So my maximum elevation is going to be 11.5. So pretty straightforward, just putting in information. And then I want to look at, this description. I'll say both lakes combined, just in case anyone opens that up. So one of the things that you will recognize with Storm Sanitary Analysis 2015 and 2016 is it doesn't allow you to put spaces in some of these descriptions and what you're typing in. Okay, so just something to keep in mind if you run into that. So my water elevation is going to be 5.5. My ponded area, so where do I get my ponded area from? So it's 10 acres. And if you do 10 acres times an acre, we're going to get that ponded area in terms of feet. So this ponded area is going to be 4, 3, 5, 6 with 2 zeros. Pretty straightforward. That's the first part in terms of the lake. And I can leave these dialog boxes open if I wanted to. So the second part is I want to address this receiving body where this is going out in terms of the structure. So I need to put an outfall here. So I'm just going to pick on outfall, and I'll add the outfall. So from my outfall, you know, I need to connect from my document is it has two weirs. So I need to define a weir. So in HydroFlow, it's a little bit different. It kind of shows you the structure and where the weirs is going to be in the orifice. And it's a little bit different in Storm Sanitary Analysis. Okay, just want to make sure. No, we're going to do those later. So we're just going to put in an outfall. So one of the things that we need to do is attach the weirs to the outfall. And again, this is schematic. So I'll just go right up here. You can see, you can add an orifice, you can add a weir. So I'm just going to add a weir. And I'll just pick on my storage node. And then I'll just pick right near here. And then I'll pick on my outfall. And then I'm going to pick my select button. And from my select button, I'm just going to double pick on that weir. So there's two weirs that they've specified in here. So the first weir, it's a V notch. So I just kind of give things an idea in terms of what I'm going to be working with. So this V notch, the first thing I'm going to do is look at the physical properties. So the crest elevation for that V notch is going to be 5.5. The crest length, and you notice as soon as I pick my crest length, it's looking at my rating curve. One of the things that you're going to run into with Storm Sanitary Analysis is it doesn't like 0 in terms of the weirs for your crest length. So what I typically will do is I'll put in 0.1. So when I pick my next, then it gives me my rating curve. And I can put in 0.00, whatever I want in terms of that. And then my weir total height, I'm going to put in 1. And this is going to be a trapezoidal shape. And this is going to be 1 to 0.2. In terms of my side slopes, and my discharge coefficient is 3.3. That's going to be fine. And that's my first weir. Pretty straightforward. If you wanted to add a flap gate and things like, you could do that. But you can clearly see this weir, because I'm building this model, it goes from the lake to the outfall. So then I'll just add another weir. So my second weir is going to be rectangular. So I'll just type in rectangular. In that crest elevation, it's a little bit higher. It's going to be 6.5. So a foot above. And then the crest length is going to be 1.5. And then the total height is going to be 4.3. And again, these are just not numbers I'm making up. Everything is in this document. And even if you wanted to go online to the South Florida Water Management and download, they have 5 examples in terms of hydrology. One is going to be residential, one is commercial, one is going to be a mixed use, and I forgot what the other 2 are. But so now that we have that rectangular weir, we got the V-notch weir, we got the rectangular weir, and we got the same side slopes, then I can go and close that. Okay, so now how we need to connect everything because we have this subbasin and we got this lake. Now the lake is connected to the discharge, which is the outfall down there, but we haven't connected the subbasin to the lake. Why are we connecting the subbasin to the lake? Because the subbasin has the curve numbers, they have the percentages of the pervious and impervious that we've put in already that we're pushing into the lake. So I'm going to pick my select button and I'm going to right click on it and select connect to. And you can see there's other properties and things that you can do in terms of editing the coordinates and changing the vertices. You can do all those things and recomputing area, making duplicates. But I just want to connect it to that storage node for the lake. So pretty straightforward. And then clearly there's some design criteria and computations in there and surface storage about the lake and what the curve number is. But what I, excuse me, but what I need to be able to do is I need to put in the storage, the shape, and the storage curve of this lake. So I just double click on the lake. And right now it says it's functional, but that's not the type of storage that we want. We want a storage curve. One of the things that you want to be able to keep in mind from Civil 3D, if you lay out a pond in Civil 3D and you use the stage storage, if you save that stage storage to a table, that table comes right into Storm Sanitary Analysis. Just an FYI. So from this storage curve, we want to go in and add information about the storage curve. So we'll just pick on it one time and I'll select add and I will call this storage. Pretty straightforward. And then from that, you can see if we were doing some underground storage, it has an underground storage calculator. We can do depth versus area in terms of the area curve, or we can do depth versus volume. We want to do depth versus volume. Previous to this webinar, I have calculated what that storage curve data is. So at 0, is at 0. And then at 3.5 feet stage, it's going to be a volume of 1524 600. And when I hit my next depth, it's showing me what that depth is in terms of the volume. So my next depth is going to be at 4 and it goes up a half a foot. And then from that, we're going to speed it up and say 259056. And then we'll go a little bit further down. And we're going to go 4.5. And then at 4.5, we're going to put in 341 5104. And then at 5, we're going to put in 45955 580. And then at 6, we're going to put in 604 6128. So from that, I've put in my storage curve data. From that storage curve data, I just closes now. And I can close that. So now we've got everything kind of set up. If I pushed this little running man up here to run my analysis, it's going to give me an issue. It should give me an issue. So just in case, I'll just run it. So it says, okay, you try to perform analysis. The analysis was unsuccessful due to the fact. Why was that unsuccessful? It says you have not given it a simulation period. You haven't defined any storms to run the analysis. So I'm just going to close that. So the reason I did that is so you can kind of get a feel for the type of error messages that will come up. So if I just double click on my time series, no big deal. On my time series, I want to add in a time series. So my first one, if I remember back, we're doing a 10-year, a 25-year, and a 100-year storm. So here's a 10-year, 24-hour, and we're going to use standard rainfall. When I go into my rainfall designer, it's giving me information. So we are in Florida, and we are going to be in Palm Beach, and it's going to be a 10-year storm. It automatically tells me what the rainfall depth is for my 10-year storm. The biggest difference is in Florida, they run these 24, 72-hour rainfall events in terms of simulation. And, you know, we typically do SCS up north, type 1, 24-hour, or type 2, 24-hour. So we're going to do it South Florida Water Management District, 24-hour, just giving you an idea of the different areas of the country that you have accessible information for straight out of the box. So that's my 10-year storm. And then we're just going to add another one. I'm going to do 25-year. And I'm going to use my rainfall designer, and I'm just speeding it up a little bit because we got the gist. And for my 25-year, this is not going to be a 24, this is going to be a 72-hour storm. Let's select OK. And then I'll add another time series in, and that's going to be my 100-year, 24-hour. I'm going to create my rainfall designer. It's cumulative and intensity. If I came in, I'm going to select my 100-year storm and 72 hours. So back at the beginning, 9 inches for my 10-year storm, 11 inches for my 25-year storm, and then 100-year was 14 inches. So that's like the drive, the first floor, that kind of information that we want to be aware of. So we've created that storm, and then now we want to set the analysis options. So under analysis, when we pick analysis, we go to analysis options. We want to run a 3-day storm. This 3-day storm is going to be 31st for a 3-day storm, and it puts 3-day in there. And then my storm selection, I want to be able to run multiple storms at once. So I'm going to select multiple storms, and then I'm just going to pick my 10-year and my 25-year and my 100-year. And then I have to provide an output file for those, or it's going to give me an error, and it's going to tell me specifically you don't have an output file. So it's just those kind of things that you want to be aware of. So, and where do I want to put these? I would put those in my project folder. So in my project folder, I'm just going to come here and just select on South Florida. So I'm just going to put them right in here. So this is going to be my 10-year. Save it. This is going to be my 25-year. Save it. And this is going to be my 100-year. Now save it. So then I'll select OK. And I'm going to run my analysis. So it runs through my analysis for my 3 different storms. So I'm just going to select OK. Typically, this comes with the default. Anytime the simulation is 0 to 5%, you're in pretty good standing in terms of your continuity error. So I'll select OK. And then if I pick on this, it's just giving me information. So this data right here, so I found those storms. So this data, the invert elevation of that, I'm just gonna put at 0.5. It's no big deal. And I just want to be able, so one of the things that you will run into when you're working with storm and sanitary analysis previous to 2018, those two orifices that I put in, and the two weirs that I put in the previous versions of storm and sanitary analysis, it doesn't allow you to put two weirs into a single structure. So again, there's a couple things that have kind of changed. But if I come back here, now I can select time series plot, and then I can open that solution. So if I right click, pick on it and select open solution, those solutions, that's in water quality. So I'll come here, I'll close that, and we'll just go right here. And then those solutions should be placed here, South Florida Water Management. So there's my solutions. The issue that I have with this is it doesn't allow you to select multiple solutions. So I have to open them up individually. So I'm gonna go ahead and open them up individually, no big deal. There's no easy button that I've found yet. So, I mean, some things we just have to put up with. So one of the things that we're checking for is we need to determine runoff. So if I go to subbasins and I pick on runoff and pick that subbasin 1, there's my runoff for subbasin 1. It's kind of pushed out because of the time series is not a 24-hour event, it's a 72-hour event. So you want to keep that in mind. So if I go to runoff, and there's my other subbasin. So remember, one is a 10-year, one is a 24-hour event, one is a 25-hour, 72-hour event. And then we'll come in and we'll look at our 100-year storm. Okay, pretty straightforward. So as you can see, maximum runoff duration and then volume down at the bottom, clearly you can see from the different storm events. So the other thing that we want to look for is flooding from that lake. So we want to look at depth of water. So if we come here to our nodes, we can see depth. When I pick on depth, we can tell it what the lake is. What that outfall is getting. So we'll come down to nodes here, and we'll go to depth, not head, and we'll see what that lake. And from that, I'm going to look here real quick in terms of our depth. And then we're going to look to see what the head is to determine that first floor, second floor, first floor in terms of the information. So we'll put that in. So all the same, it's all the same lake. So when we go now, we close that. Scroll up. Now if we go to, I didn't pick that one on purpose. Now if we go to head, we can say specifically what that is. Now, remember our elevation that we were looking at with the first floor, or the elevation that we were looking at was 9.9, 9.4. in terms of the road. So we're underneath that for the road. If we look right there for the road, so pretty straightforward. And then if we look at our 25 year, to see where that lake is, that's at 9.22. Then for our 100 year, we'll look at the head. And that's 9.67. So a couple things to consider in reference to just using storm and sanitary analysis. You could use storm and sanitary analysis. It's just a matter of, what you want to be able to do in terms of the project. So the roads for the rainfall amounts for the 24 hour for the roads was 9 inches for the roads. And clearly we're below that for the 24 hour, which is that first one. For the design 25 year storm, 11 inches. For the 72 hour, clearly we're below that. And then the 100 year is 14. So it's just some things, and all I really wanted to do is kind of simulate some of the tools that we would use just to do something residential. One of the things that you will also see is this is a multi-building, two lakes, and then a lot of pavement. And then it's going out to this outfall out here. The other thing that we want to take a look at in terms of the samples. So I'm not going to save any of these changes. Clearly, being able to run simulation and do those things, you can do that with storm and sanitary analysis. So there's some advantages to using it. So if I go to samples and I go into my residential, so residential project, we'll do this post development. And I'll come all the way down to this post development. If I bring up this post development, similarities, but just a lot more inclusive in terms of what you want to be able to use. So it's just a residential site. The challenge to these is they've already been created and they don't go step by step. So those are some challenges. But as you can see here, under this residential, it does at least take you to tutorials step by step, in terms of that. And that's an SPF file format, but there's some things in there. And if anyone has like questions about some samples, I have some samples that I can allow you to take a look at that walk you through step by step in terms of storm and sanitary analysis. If you want to get a little bit more complex, that's a different story, but just some quick samples in terms of how you utilize these things. Because if I did something like a car lot, there is a, let me go back one, under samples. There's an auto dealership. And from this auto dealership, if I open it up, and we have a couple more minutes, then I'm going to take a poll and some questions. So some different things in reference to what you want to be able to do, bring in TIFF images, but being able to kind of lay these things out. Those are some of the things that those samples provide for you also. So one of the things that we did want to do is we did want to take a poll. And from that poll, if we come back here, we did want to take a poll in terms of what are some of the overall capabilities of storm and sanitary analysis?
Oh, sorry, Ken, I went to the poll as far as what hydrology programs are you using?
Oh, okay, that sounds good. Okay, Mark, well, how about you go ahead and ask those questions, and if any technical ones come up, then I'll address those.
Yeah, so again, we just again wanted to get your feel from the audience as far as what you guys are using as far as hydrology programs today. So again, if you have the opportunity just to, we'll give it a few seconds here. I know we're running short on time. We've got 5 minutes left to the scheduled time. So just trying to fit everything in, but I think we got quite a few voted here. Give you a few seconds more to finish off polling, and then we'll close that out. Okay, we're gonna close that out right now. Looks like we're pretty stable here, and I'll show the results as well. So we see here the results again from kind of a mixture all the way across the board. A lot of people storm CADs, 18% using Storm and Sanitary. So we still got quite a bit can learn from this and use Storm and Sanitary. That's great. So Ken, again, any comments, and we can go on to the questions if you like, or if you want the rest of the polls.
No, there's a lot of tools out there in reference to what individuals are using, and clearly, I make reference to it because it comes straight with Civil 3D, and most of you probably have Civil 3D, so you probably want to take advantages of working with tools that come straight out of the box opposed to external ones if they do the same thing. So there are some challenges in terms of StormCAD and Civil Storm and HEC-RAS, but clearly if you can do those things straight out of the box with Civil 3D, you want to be able to do those to prevent from paying extra money for other products. Okay, Mark.
Especially since it integrates very well with Civil 3D. So that poll has been hidden. Did you want to go on to questions, or we got the two more poll questions?
Yeah, there was a couple questions in there, so.
So let's go to the questions. That's a great idea. So we did get an earlier question from Hemant. Again, will we be able to get a copy of the slides? And again, after the presentation is over, we're going to send out a link to the webinar. This event, this will be recorded. It has been recorded, and we will put the recording up on our YouTube page. So you'll be able to see and review this slideshow via the YouTube page. Got another question here. Again, this is kind of a broad one, but what are the overall capabilities of storm and sanitary analysis? What are the overall capabilities of storm and sanitary analysis?
Well, so some of the overall capabilities clearly, in terms of what you want to be able to do with SSA. Let me just move this around a little bit here to bring up SSA again. Some of the capabilities that for storm and sanitary analysis, you can clearly, for hydrology methods, you can do kinematic wave, steady flow, and hydrodynamic, for specifically those. And then as you start to move on in terms of hydrology methods, on pavement drainage, off pavement drainage, site, so there's a lot of different things that you can do. So the hydroflow extensions kind of allow you to do similarly the same things, but in terms of computing runoff, just for drainage basins, small sites, highly impervious sites, parking lots, roadways, inlets, gutters. So it allows you to do a multitude of different things. EPA swim, XP swim. So you have a lot of flexibility in terms of what you want to be able to do in terms of that. So that's just a few to name. Okay, Mark.
Okay, thank you for that. I know we're right at the edge here, so I need to close this out because we're right at the 1 hour time, and do want to respect your time. So Ken, any comments before I close it up?
There are some specific workflows that I've kind of put together. Again, I'm going to talk about those things in terms of a round trip. And if those of you who have the AEC collections, I am going to be doing a presentation that uses 14 of those products out of the AEC collection. And I want to be able to show you how you can use those in terms of a workflow, working on a single project. So it's, if you want to be able to look at something like that, it's a 2-hour demonstration, but I use Raster Design, Civil 3D, InfoWorks, Navisworks, Revit. So I use all those products in terms of working on one single project. So if you have an interest in that, you can shoot an email also.